Hello YouTube and welcome back to another devlog about the Montreal project. And let's jump right into the game, and I'm going to show you what is new. I implemented unit selection and movement, and as you can see, when I select, I already have a preview on where the unit can move, and it is already animated and it's turning around. And if I click outside of the range somewhere, it gets deselected, so everything there is working fine. And let me show you what was involved in actually making that work. First of all, I have now an interaction layer here, which, let me put the inspector somewhere over here, has another custom class, also a time map member and a tile map. The tile map is there to basically render the overlays, which showed you the white dots for showing which unit can move where. And then we have a highlight tile, which is the one rendering the dot. So that is what this class is basically doing. We're going to look in the code in a little bit. And then there's also this thing. I implemented dependencies that these things have. Now the tile map here, that is pretty much obvious, and actually need to resort this a little bit. But here you can see what the hell is going on here. Component asset, what's this? Here I wrote myself a special class so I can make components depend on other components based on their interface. And if I look into here, I can basically assign any component here. I will probably write myself a custom window here to pick stuff. But as you can see, if I click the wrong thing, it tells me component must be of type iGameMapInformation. And there's only one doing that. So this one. And I can also revert this. So this is prefab workflow capable. And I could also theoretically use an asset that implements that interface that would also work. And I can even overwrite this with a runtime component. So at runtime, I can assign something different to this. Obviously, that won't get serialized, but at runtime, I can basically assign a normal class that implements that interface. I'm going to show you how that works also. So let's jump right into the code. As you can see, I also switched IDEs. I'm now working with Rider, which I like quite a bit for Unity development. Haven't tested it for anything else yet, but yeah, since I had a ReSharper license anyway, improving that, upgrading that to include Rider is actually not all that much. I think it's $40 a year that you pay additionally, so that didn't seem like a big jump, and I actually quite like it. So, especially since you can actually run the unit tests for Unity inside the editor here, inside the code editor, that's kind of nice. I also have the console in here, so everything that gets printed to the console gets also printed here in the output. So including the call stack on the right here, so that's kind of nice. But I can also start Unity from here and all that kind of stuff, so that's kind of cool. Also code coverage and all the goodies that you want. But let's look at this class. That's why we're here. So we basically have an interface dependency class, which is an abstract class that includes a name for a dependencies group name, which I'm using in the foldout group. When I use that, basically everything with that foldout group gets, let me get the inspector back again, gets basically tucked into this dependency thing. That is usually what you would set up in the prefab itself, or some stuff that you can only do in the scene. Like if I reference the camera, I can only do that in the scene because that's obviously not part of the prefab. But you usually set this up once and then you close it and then the rest remains. That's actually your configuration and not just references to other components. So I define a name, so whenever I use that, it all ends up. Any field that is implementing this class automatically ends up in there. I also gave it a property order 0, so it possibly ends up at the top. And I also inline it using that, so the label looks nicer and stuff like that. That's Odin stuff, so You don't necessarily need that. Then I have a serializable enumeration, which tells me which of the current variants is the current active one. Am I using an asset that implements the interface, or am I currently using a component that implements the interface? And then I'm actually going into the abstract class that enhances this a little bit. This is just defining these two things. And in case you're wondering why I made a separate class for that, some stuff in Odin apparently, since I can do some toggle buttons here working on these enumerations, apparently that doesn't work well if it's in a generic class or for some other reason. So I put it in the base class and then it works fine. It's not a big deal. But this is actually the class where the action goes on. So we have a normal field of type T, which is a runtime replacement. Ignore all this stuff, that's just making it look nice. And I'm not showing this if the runtime replacement is not actually set. So if it's 0, or rather null, not 0, then I'm not showing this field in the editor, in the inspector. That gets only shown if this is actually set with a nice info box on top of it saying overriding runtime value, which tells me in the game that in the code something has actually overridden the value that I've set in the inspector. Then I, of course, have my dependency variant. So that's the enumeration telling me which of the two is currently active. And then I have my component implementing the interface, and I have my asset implementing the interface, and I both validate these with the help of Odin Inspector. You can write your own inspector editor class. If you're not using Odin, it just validates this, and this is what writes the error if I assign anything to this here that is not actually of that type. If I look at that, those validation, you can see it just checks whether the input is actually of the type. Otherwise, it puts out an error message, and I'm using these callbacks here that Odin offers to generate that error, but you could write that in your own inspector implementation manually. And then the big thing is this pretty large property of the actual value, which checks if there is a runtime value, we're always going to take that. So that always takes precedent. If we don't have a runtime value, then we decide based on the variant. So if we have an asset set and that asset is actually valid, so it's not null and it's of the right type, then we're going to use that. If we have set component and we have a valid component, be using that. And if neither, so either we have set asset but we don't have a valid asset, or we have set component and we don't have a valid component, then we return null. So even if we have set these valid ones, we can, by the way, set both of them, as you can see. Then we ignore one of them and we can switch back and forth between them. I already tried that at the runtime, works fine. So you can set an asset that implements the interface, and you can set a component and you can live switch between the two. Works fine. And then you can also override it with a runtime value, which I so far only use in testing. But in testing, it's really useful, because then I can actually feed a mock implementation into this, since this doesn't need to be a component or asset. And by the way, in case you don't know, components, that's basically scriptable object. No, not scriptable object. That's mono behaviors, and assets, that's our scriptable objects. I have my own base classes for those. But obviously, you can't instantiate those easily, and you can't mock them easily. So, but this thing can be just about anything that implements the interface, so I can easily put a mock in there in my unit tests. And but I didn't just write that just for the unit test. It can also become useful during runtime if you want to switch behavior. And here, if we set the behavior, I actually check what I'm actually setting here. First of all, if I set null, then I'm assuming I want this thing to be null, and not just I'm setting the currently used one to null and then I'm suddenly using something else. I'm assuming the best semantics for someone setting the value property to null is that we want it actually to be null. So I'm setting everything to null. If we're setting a component, then I'm actually setting the component and switching the active variant to component. Again, if I assign the value to it, I'm assuming that that's actually going to be the active one. But I'm not overriding the component, the asset one. I keep that in place, but I'm setting the runtime replacement to null, because if that was still in place, this thing would get overridden. If I'm assigning an asset, I'm doing the same. And if I assign a runtime replacement, I'm basically not resetting anything because I don't need to. The runtime replacement overrides it all anyway. And then I have a reset override in here. Not sure I'm actually going to need that, but in case you just want to set the runtime replacement to null, so you want to stop overriding, but you don't want to set everything to null, I offered this little message here in case you actually know that you're dealing with a dependency and not just not just the interface in your hand, then you can work with this. And then, of course, the validation method. So how is this actually being used? Well, let's take a look at some of the interfaces that use this. For example, the unit layer or the terrain layer. The terrain layer doesn't really have anything in it yet because so far that's pretty independent and doesn't get used by anything else. So the unit layer is a little bit more interesting. And as you can see here, I have an interface and then I have a unit layer implementing the interface, implementing the class. And in this case, also implementing the interface. That's a matter of choice. You don't need to do that like that, but I decided to do that because it makes me able to use this thing as if it was the dependency itself. As you can see, in reality, it just wraps every call and gives it to the value. In case the value is null, nothing happens at all. So that is fine. And anywhere I use that, let me actually check the interaction layer. Interaction layer should know the unit. Yeah, interaction layer knows the unit layer. So here I have the dependency. And as you can see, I'm giving that actually to a property here. And that property is of the actual type of the interface. So whenever I use this property, I'm working on the interface and I have no idea that I'm actually working against the dependency. If I didn't want the dependency itself to implement the interface, then I could just let this property match to value and that would also work fine. But usually that shouldn't be a big deal because classes shouldn't be so big that they have tons of methods anyway. So implementing them quickly as a wrapper version is usually not a big deal, and it makes using the class a little bit more simple. So that's what I did there. That's just a choice that I did. Just need to write maybe a little bit of a better editor. So whenever I pick something to plug in here, it is actually only showing me whatever is implementing this stuff. So far, I don't have that many components in the game yet, but as soon as that gets a little too crowded, I'm probably going to write myself a custom editor. So then we have the selected unit, which does a whole bunch of stuff in here, deselecting the old one, selecting the new one, writing out messages and all kinds of stuff. But the interesting stuff is actually more this here. The set dirty I only use because this is actually not a serialized property. It just gets shown in the inspector, and I want that to always get updated whenever I set a new value. So that's what this is for. It's actually implemented in the base class, and it actually only works in the Unity editor. It sets this component dirty if we are in the editor, so at runtime this won't do anything because then we don't have an inspector. So let's go back. And then here I'm updating actually the movement highlight where we compute whatever field, whatever cell on the Hex-Grid the unit can actually move to. So that's pretty much what these things are doing. And here we actually go into event handling, and there something new has happened. I've changed the way my events work, and I'm actually going to do a couple more things with that. But for now, these still are event bases, which are, if you click through all the hierarchy here, still assets. I'm probably going to change that and turn these into normal classes because right now they still live as actual assets in my editor here, in my project. But I figured out that I probably have a better way of test triggering those than writing an inspector for these to trigger them and have them as assets in here. Since I'm working alone, I don't need a designer to be able to create completely new events or stuff like that. I'm fine with having them just in code, and I can write my own components to trigger them somewhere else, probably figuring them all out by reflection. So I'm going to change that real soon. But this was an experimentation. I needed to figure out how to best call messages or send messages in Unity to other components, and this seemed like a good way. And it still is. I just need to get rid of them being assets. But the real important thing is that I'm now using UniRX, which you can see here. So these are now observables. If you look at the interface is now implementing observable and adding a raise method. So go back here, you can see raise method, subscribe method, and that takes an observer and gives a disposable subscription back. And with that, I can now do nice stuff like this. In the onEnable function, I can just say get event. This is actually internally calling the the event aggregator, which is also linked up in here by interface. And that calls find event. So the event aggregator is still in here as a system that holds all the events in the inspector, which you can't see right now, but I think I showed that last time. Nope, I didn't want to show you my Skype. Anyway, and then I can basically do everything with it that you can do with our observable. Now, this is not really exciting because here I'm just subscribing to it, but it already shows you how I'm getting rid of the subscriptions. I'm adding them here to event subscriptions, which I clear and disable. So whenever it gets disabled, all the event subscription go away. And these event subscriptions are just a composite disposable that lives in the component base class. So this is just a disposable where you can push other disposables into it. And if you call clear, it's basically the collection, and everything in the collection gets disposed. If you're wondering, I'm not calling disposed on this because that does something different. If you call dispose on this, then it also disposes everything that's inside, but it also will automatically dispose anything that gets put into it later. And I don't want that. I want new subscriptions to still be alive later on. So that's what's happening here. And if I go actually into the game map information, that is actually subscribing. That is just a class that holds all the data about the grid, or accesses the data about the grid. And if you look in here, I'm actually doing a little bit more of a interesting thing. First of all, I'm getting an event that gets created by an input subscription that just basically does this. Every update, we basically check whether the mouse is down. This down here just prints out the current cell coordinate. I think you saw that. Quickly start up the game. There, up there in the corner, you can see there are the cell coordinates that gets printed out down here. But the really interesting thing is this. Here I take the left down. I take everything where actually my dependencies are valid. Otherwise, this would cause an exception inside link here. Then I'm translating the mouse position into the cell position using the main camera and the layout grid. Then I'm checking whether whatever position I clicked on is actually a valid terrain position. So whether there's actually a terrain type at that position. Otherwise, I clicked on a black out of the map grid position. And then I'm subscribing to those and calling them as a valid cell was clicked event, and I'm raising that. So I'm translating this event into a new event, and I'm adding that to my subscription. And this is the event that the interaction layer is reacting to. And that is doing a bunch of stuff on all cell clicked. It's figuring out, have we clicked on a new unit? If yes, then we selected it. If we clicked on a unit that was already selected, then we deselected. And if we clicked on a position that the selected unit can reach, then we move it to that position. And I'm going to show you that in a bit. But that's basically what I did with events. Events are all observables now, and that will remain the same. I'm just going to change the way you actually get to the events and how you throw events. I'm not going to use an event aggregator anymore, at least not the one that I'm using right now. I'm getting rid of all this asset stuff. Events won't be assets in the future. That was an idea, but it's not what I need for this project in terms of workflow. Anyway, let's look at one last thing that I added, which is, as I mentioned, unit movement. Go back in here, as you can see, this is actually a async event handler. And if I receive a click on a cell that is in distance of a unit that is already selected, then I want to move the selected unit to that position. So I'm grabbing the movement unit. I'm doing that here in a temporary variable because while the unit is moving, I want it to not be selected anymore. So I'm setting the selected unit property to null. That's why I'm saving this in a temporary variable. And then I'm doing a unit layer, move unit async, and then I'm saying use busy ticket. So what the hell is going on with this? A busy ticket lives actually in, let me see here, in the busy helper. The busy helper is something that I originally wrote some time ago for WPF, actually for a business application, to basically set a loading bar or a busy indicator whenever something async is going on. And here I need something similar, even though right now I don't need to set anything in the UI. But basically everything this is doing is it gives you a ticket if you want one, and it initializes that ticket. That ticket sets a counter on the busy watcher up, and when you dispose of the ticket, it counts it down again. Now currently this is probably not thread safe, but right now I don't need it to be because I don't expect to ever use this in a background thread, so keep that in mind. This is probably not thread safe, but again, I don't need it to be. And I have a isBusy property that tells me whether the busy counter is 0. If not, then someone is still holding a ticket. So how do you use this thing? Well, I have a little bit of a explanation here already. You basically start any operation that you want, and then you say using busy helper ticket. And how does that work? Well, for that, we need to look into the task extensions, what this using is actually doing. Anything this using extension method is doing, it basically takes the task and the ticket, and it basically wraps the execution of the task into a using block using the ticket, which is pretty easy. So as soon as the async operation is gone, the ticket gets disposed, so we're good. Basically just so you don't have to write the using block everywhere. And how that gets used, you could see here, await this thing using the busy ticket. So this thing turns the isBusy property of the busy watcher that every component has to false as long as this operation is running. And as soon as it returns, it sets the busy ticket counter down. And then if you only had that one operation going on, it should be isBusy true again. If you look in here, that isBusy ticket is just delegating to the busy helper property. So what am I using this for? Well, here I'm basically saying if we're already busy, I don't want to handle any more cell clicks. Which means while a unit is moving, I don't want to take any interactions. I don't want to click cells, select other units, or do anything else until the unit has finished moving. So that's what I can do with this. I can, wherever I want, I can check this isBusy property. And if that's the case, then some async operation is going on. I'm also logging that here just for debug purposes, saying, okay, this has been ignored because an ongoing async operation. And then I take clicks again once this has returned. In case you're wondering, from what I know, Unity has implemented their own synchronization context, so you don't need to worry about this. If you start this in an update or something like that, it will end up again in an update. So if this was started in an update, it will finish in an update. Unity has written something for that. So you don't need to write your own synchronization context for await or anything like that. That has already been taken care of by Unity. So what is actually happening in here? Let's look. The actual movement is implemented by the unit layer interface. So let's look into the implementation in the actual unit layer. Of course, we're checking if we're active. I could probably get rid of this. Actually, this is probably not necessary anymore. I'm going to check this. Whether I actually need to do this. I might actually have to do this. Either way. We take the positions where we want to use it, unit to move it, and so on, and whatever. And we have a couple of lookups where I need to update the position. But the interesting thing is actually this. We call move to async with the new position. So the actual movement is taking place inside the unit. And here we're no longer dealing with cell positions. This is actually the position that has been already translated into world positions. So this is the sprite actually moving to a new transform position that has nothing to do with cell. This is hopefully a center of a new cell. But that's what the unit layer took care of. The unit is just dealing with, okay, you gave me coordinates in the world coordinates, or in my local space anyway. That's where I'm going to move. So let's look at the implementation of that. And here I'm actually using a tween to do this animation. And for the tween, to make that available, I actually wrote my own awaiter in the tween extension. Here I have my own little interfaces. The Awaiter interface doesn't actually exist. I wrote it, however, because that's exactly what an awaiter needs to look like. And there's also an Awaitable that gives you an awaiter. Let's go back to the unit. Oh, actually to the tween extensions. So what I'm actually doing here is I'm saving the tween as soon as the awaiter gets generated. Get result, this doesn't have a result, it only gives finish, so the get result is void. I don't need to do anything at all in there. This thing also needs an iCompleted function. Basically nothing of this gets ever called by anybody manually. This is for the compiler to build the state machine for async await, but you need to implement this stuff if you want to build your own awaiters. And the onCompleted function, the way this works is basically if this starts, the compiler will go see, okay, is this completed? If it is already completed, it will immediately call get result and try to get a result. In case of a task that doesn't have a return value, that doesn't do anything. Otherwise, this would return whatever. You can have a task of integer, then get result would be of type integer. In this case, this doesn't have anything. If it isn't completed, then it will call, then it will wait for this to, or rather it will call this, and it will pass a continuation. That's the code that gets executed once this thing has been completed. So I'm storing this, and I'm basically making a while loop, waiting for the tween state to not be running anymore, which means the tween has finished or has been interrupted. And I'm basically waiting one frame time every time this isn't the case. I could probably implement something here, wait for new update or something by it, but I haven't written an awaiter for that yet. I have written an awaiter for time span, as you can see. I don't need to do task delay here. I can now await time spans directly, but that's not the point. I'm just waiting until that's the case. So as soon as the tween has finished, I'm setting is completed to 2, and then I'm calling the continuation. That's basically how you can write a very easy awaiter. If you look, for example, in the time span expansion, I'm giving out a normal task awaiter. That's a class that actually exists in the runtime. And here I'm just doing, I'm just translating the get await to time span to a normal task delay of time span, and then I'm already getting the awaiter for that task, which here I can just get an awaiter that is already implemented by the runtime. By the base class library, rather, not by the runtime. So that is easy to implement. For the tween, I needed to do a little bit more magic myself, but it's still pretty easy. And with this, I can just await tweens. So that's pretty cool, and it works fine, as you can see. As long as a unit movement is going on, I can't click on anything, but as soon as it's done, I can start clicking again. So that works out perfectly fine. And I think I will call it a video with that, because this is a long video because I had a lot to tell. I will try to record these a little bit more regularly, because there's a lot happening. I'm currently working on a new thing where I will implement some, let me actually show you, where do I have it? Scenes, testing, where I'm actually implementing some algorithms on Hex-Grid. Right now, I don't have a whole lot going on there yet, but I have basically two things. If I move the inspector back here again, and I go on my algorithms layer here, you can see I can now switch which algorithms I'm going to pick. Right now I only have simple selection, which is obviously pretty easy. And then I have neighbors, which calculates the neighbors of a hex, the valid ones. And of course, this will get more complicated and do more grid operations, including, of course, A-star pathfinding and everything else that I need. So that's what I'm working on right now, so you can look forward to that one. And as soon as that gets implemented, the units won't move in a straight line anymore. They will actually follow a proper path, and that will also take movement points on the terrain types into account. But that's the story for next time. Until then, happy gaming, folks, and I'll see you on the next one.